Hey students, this is Mr. Sharp again, here for the fourth video for our series in technology, engineering, and design, specifically in our fourth unit for design. Today, we're going to be diving into something different that we haven't done yet in this course, or something you may have thought we have done, and that's going to be related to a little bit of math. No, don't worry about that. Don't worry. You won't be doing any kind of math equations today, but I am going to be giving you some things to put in your toolkit for later on when you go into the next courses that will help you. So today we're going to be discussing how engineers actually put their ideas and designs onto paper and onto mathematical equations, and to give us the idea how we can build this product before we even go into the manufacturing. Why do we do this? Well, it's because before we even mass produce a product that we are designing or even put it into creating the real prototype for it, we want to make sure that it's done correctly. We want to make sure that it works as efficiently as possible, that we want it to. It produces the output that we want it to, and we want to make sure that we test run it through a series from either the computer, on paper, or by building a physical model before it's actually designed, in order for us to identify any errors. So this is why modeling and prototyping is very important. That's the essence of this lesson for today. So if we think about how we can describe an object, any object, it can be described in three ways. It can be either written down, spoken about, described verbally. It can be talked about mathematically. For example, we know that a pair of scissors, when it's closed, it has an angle of 0, but when it's opened, it can be opened at either a 90 or a 70-degree angle, depending upon the size of the scissors. And sometimes it can be described graphically. We can draw it out and we can display it conceptually. Those three things are what we have to do first before we start to build our actual product, in order for us to decide, is this product going to be successful? So there's a lot to discuss today, and I'm going to try to keep it short. So conceptual models is what we start with first. This is how we sketch or draw out our design first. Conceptual models can include a variety of different things, and we'll be talking about them in notes today. Isometric, or models that are drawn at a 30-degree angle from the side view. Oblique drawings, same thing, except they're drawn at a 45-degree angle. Perspective, where a drawing can be converged onto more than just 2 points, but the perspective drawing also gives us a more realistic view of the model. Or orthographic, meaning that we can see it from three sides, from the top down. So these drawings will give examples in class. However, you need to understand, no matter which drawing you choose, you want to give your design, your drawing, not a two-dimensional flat design. We can't see a three-dimensional structure on just a piece of paper without giving it the details from both the height, the width, and the depth of this product. So with that, we move on into how we can describe our models mathematically. So if you've ever thought about it, every design that you're putting together, that you're wanting to build as your product, is going to have some mathematical properties to it, whether it be measuring the different sides or different lengths of materials that you're using, to how you can mathematically prove that the input that you're putting into your process is going to generate this amount of output that you desire. So mathematically, we can prove different things, and we're not going to give you too many mathematical properties in this course. That'll be in technological design, engineering design. However, what we will give you today, and you'll be practicing this today, is how you can calculate two-dimensional sizes and three-dimensional sizes. So if you ever think about this, if you're drawing a flat square, you can only measure two sides to actually understand what the area of this square, this rectangle is. Now, if we make that into an isometric drawing and try to measure this cube, we have three sides that we have to work with instead. And that's just the height, the width, and the depth of this cube now. It's not a square. So we calculate for volume, not for area. So for that example, we would multiply the three sides together, for the volume, height, width, and depth. And those are just examples about how we can describe a model mathematically. The last way is which is usually the fun part, building the physical model. This is not meant to be a functioning model, and it's not meant to be the real prototype, but it's meant to give us a physical representation of how this product will look in the end result. For example, before we go and build buildings or structures, we'd like to build a physical model that's to scale, that can fit easily on a table, for us to visually see how this product, or this building rather, will look in the real world. So those are going to be the three biggest things that I want you to get from this lesson today about how we can describe a product or anything that we do or create in technology in three different ways: mathematically, verbally, and physically. The lesson today, hopefully it won't be too dull for you, but I want you to make sure that you take those ways to calculate volume and area with you and put them in your toolkit, because in the next courses you're going to be learning how to calculate for the simple machines, for hydraulic power, maybe even measure electrical resistance. These are going to be things that you have to do in the next steps. So with that, I hope you guys have a good day, and join me again next time when we talk about how we can collect data. Have a good one.